Jared here, and in this video I'm going to go over a few more problems about rules of exponents. There are plenty of videos that I've made available to you through YouTube and also through my website, so you can check out the other rules, but I just wanted to go over these last few really quickly. So, if we had a problem like 6 to the third raised to the negative second power, we know that the rule says that when you are taking a power to a power, then what you're supposed to do is to multiply the exponents. So that's a to the m times n. Whatever m is, you write that down. Whatever n is, you write that down. So that's m times n. So in this problem, then, you're going to end up doing 6 to the 3 times negative 2. 3 times negative 2. So, very simply, 3 times negative 2 is 6, because 3 times 2 is 6, but a positive times a negative is a negative. So this is now 6 to the 6th power. It's going to make that a little larger. So 6 to the negative 6th power. Well, now you have a negative exponent, but none of your choices have negative exponents, so you need to evaluate the negative exponent. And we learned that a negative exponent takes the base and flips it from either the numerator to the denominator or from the denominator to the numerator. And you can think of it like this. The negative sign is like the sting on a bee. Anytime a bee stings someone, that sting disappears and the bee is still there. So the person that's stung, though, is going to run from one side of the room to the other. So what's going to happen with this 6? When the negative 6 stings the base, it's going to go from the top to the bottom. Now the sting is still attached, but you can't see it anymore because now it's in 6. So it ran from the top to the bottom, so it flips the fraction and becomes positive. Whenever you use the negative sign is going to be gone after you use it. So now we have 1 over 6 to the 6th power. And from here, we know that it obviously means that this is wrong because it should be 1 over 6 to the 6th. We also know that this is wrong again because it should be a fraction. But then you look again and you say, well, is it 1 over 6 or 1 over 46,656? Well, what we do know is that there's no way that 6 to the 6th and 1 over 6 to the 6th can be the same thing. So by process of elimination, the other answer must be C. The next one, 3 to the 2nd power is then raised to the 5th power, divided by 3 to the 5th power. Well, what's happening here? Well, again, we have our power of a product rule, or I'm sorry, power of a power rule, which says again, a to the m raised to the nth power is a to the m times n. A to the m times n. And so that means here we're going to be doing 3 to the 2 times 5. And that's divided by 3 to the 5th. I'm not going to try to do that math before I write down what I'm supposed to do. So then from there we have 3 to the 10th power divided by 3 to the 5th power. And so now that we've done with that, we have 3 to the 10 minus 5. And so, because whenever you're dividing, you're supposed to keep the base and subtract the exponents. Since the bases are the same, you're now going to end up with 3 to the 5th. So this problem looked complex, but it really wasn't. It was just multiple things in the same problem. 3 to the 5th. Our last problem is the one that we think is complex, but again, it's really not. If 2 to the negative 2nd times 2 to the negative 3rd, 5 to the negative 10th over 5 to the negative 12th, 7 to the 8th over 7 to the 8th, 4 squared times 4 to the negative 1st power. And we're supposed to take these and we're supposed to put them in order from greatest to least. Okay? Well, then all we have to do is simplify each of the expressions. And once we simplify all 4 expressions, we'll then be able to tell what goes in what order. So I'm going to kind of ignore these spaces for right now. And so if I have 2 to the negative second, I'm going to use a space even though this isn't where it necessarily belongs. It'll be 2 to the, since you're multiplying bases with the same exponent, negative 2 plus negative 3. Now, we know the what. Even if we didn't know how to add these two integers, we should know that they're supposed to be added. Now, how do you add them? Well, essentially, we look at it like this. We know the base is going to stay the same. So with the integers, if we start off with negative 2 and we add 3 more negatives, so if you have 2 negatives and you add 3 more negatives, they're going to be even more negative. So you're going to have 2 plus 3, which is going to be negative 5. The short rule is if the signs are the same, you keep the sign and add. If the signs are different, you find the difference. So this is 2 to the negative 5. Again, since it's a negative exponent, b sting, the 2 runs from the top to the bottom, so that's 1 over 2 to the 5th. No more sting is visible. We're going to leave it right there. 5 to the negative 10th over 5 to the negative 12th will be 5 to the negative 10 minus negative 12, because we know that anytime you're dividing powers with the same base, you keep the base and you subtract the exponents. It doesn't matter what the signs are, you need to write out that you're supposed to subtract it. So if you know you're supposed to subtract it, now you go to increasing to more rules. For integers, well, when you have a negative being subtracted by a negative, you really should just change it to addition of a positive. Why? Because if you take negativity away from a situation, that makes it better. So by taking these 12 negatives away, it's just like adding 12. If you have a $12 deduction in your bank account and they take that $12 deduction away, your account balance goes up by $12, so you add 12. Well, now that you have that, you look, and again, the rule for addition is if the signs are the same, you keep the sign and you add. If the signs are different, negative and positive, you find the difference. The difference between 12 and 10 is 2, and you give the sign of the larger number, which in this case is positive, so that should be 5 to the second power. The signs are different, find the difference. 12 minus 10 is 2. 12 is positive and it's larger than 10, so the sign is going to be positive. So 5 squared, simplify 5 squared, and you get 25. Which, by the way, I'll go ahead and tell you that this is 1 over 2 to the 5th, so that's 1 over 5, 2, so that's 2 times 2 times 2 times 2 times 2, and when you take the time to write it out, you'll see that that's 1 over 32. 7 to the 8th over 7 to the 8th will be 7 to the 8 minus 8, because you're dividing the powers, so you keep the base and subtract the exponents. So that's 7 to the 0. 7 to the 0 is 1. 4 squared times 4 to the negative 1 is 4 to the 2 plus negative 1, because you're multiplying powers with the same base, so you keep the base and add the exponents. We go back again to the rules for addition. If the signs are the same, you keep the sign and add like here. But if the signs are different, you find the difference. So that's going to be 2 minus 1, which is, 2 minus 1, which is going to be 1. You give the sign of the larger number. 2 is larger than 1. So since 2 is positive, the answer is positive. So that means we end up with 4 to the first power. 4 to the first power is just 4. So now that we have all of our numbers in standard form, we can compare them easily. So if I look, the largest number is going to be 25. So that's the first largest number. The second largest number is going to be 4. The third largest number is going to be 1. And the smallest number is going to be 1 over 32, because obviously 1 divided by 32 will be less than 1. So at this point, I'm now going to put all of my answers in order. So I knew that this came, so this is 1, 4. So what I would do on the actual test, if I can find that really quickly, is I just have to slide my answer choices in that manner. So I know that this was the first one, this was the second one, because that was really 4, this was really 1, and this was 1 over 32. So that's all I would do. So it's not that complex. It's really just asking you to do all 4 of the different choices and then put the choices in order based on the value. So I hope that helps. If you have any issues with this while you're studying tonight, please feel free to communicate with me. But work well.